You sit down to watch a movie, but someone else is downloading a massive update, and suddenly you're staring at a frozen screen. The shared wireless network is entirely jammed. The same problem applies to your home security. Modern wireless cameras run on internal lithium batteries. A sudden drop in temperature will quickly drain those batteries, shutting down your exterior monitoring exactly when a severe winter storm rolls in. Look at a standard new build today. The contractor might give you a wireless doorbell and a Wi-Fi thermostat, check a box, and label it a finished smart home. But modern, energy-efficient houses are built airtight, packed with thick insulation and dense materials. Those heavy physical layers act as a wall for wireless signals, causing your connection to drop out entirely in certain rooms. To bypass those barriers, you need to build a digital nervous system. This is a network of physical cables hidden deep inside the walls of your home, routing information directly to where it is needed. The rule for preparing your house for the future is simple. If a piece of technology does not physically move around the house, it requires a dedicated, physical wire. Behind the drywall, the nerve endings of this system are made of Category 6A cable. Think of this specific cable as a massive, high-speed pipe for your data. Right now, a standard wire can handle streaming a high-definition movie. But 10 years from now, you might be pulling down massive local data backups or running ultra-high-definition virtual reality headsets, which require exponentially more capacity. These cables are built to carry that future weight. This animated diagram illustrates exactly how data stays protected. The Category 6A cable's outer layer contains a physical shield, blocking invisible electromagnetic interference radiating from standard household power lines. Even with shielding, installation requires precise planning. Data lines must remain 12 inches away from power lines inside walls. If they cross, they must intersect strictly at a 90-degree angle to keep the signal completely clean. Looking at this diagram, you can see how physical handling affects digital speed. Data flows continuously through the gently curved cable, but the moment an electrician bends the wire into a sharp 90-degree kink, the flow chokes and speed drops. By choosing a shielded cable and ensuring your contractors treat it with a gentle radius, you guarantee a clear, high-speed superhighway for your home's data. Let's step back outside to look at how the home defends itself. When extreme weather hits, exterior security monitoring is vital, but it is also highly vulnerable to the environment. As we saw earlier, freezing temperatures drain battery life rapidly. A camera relying on a lithium battery and a wireless signal will simply die in the middle of a cold snap. To solve this, you can use a technology called Power over Ethernet. Instead of relying on a battery, the camera gets hardwired directly into the house. This diagram shows how Power over Ethernet works. A single cable plugs into the camera. Inside, high-definition video travels back into the house, while electrical power flows out to the camera. Receiving continuous electricity, the internal processor generates heat. This warmth keeps the circuitry operating smoothly, allowing it to survive sub-zero freezing conditions. You never have to climb a ladder to replace a dead camera battery again. Delivering both power and network connection through one cable ensures your security system stays online through the heaviest blizzards. Deep inside the mechanical room of the house sits a large metal box called a media panel. This acts as the central brain where all the individual wires connect. This skeletal diagram demonstrates the home run wiring rule. Every single data wire starts at a specific room and runs continuously, without breaks, straight back to the central panel. They never daisy chain. By forcing wires to converge here, you store all internet equipment inside the mechanical room, completely removing messy black boxes from your living room shelves. The physical wiring of your lights also needs careful planning. If you want to install automated smart light switches in the future, those switches require constant electricity to function. You must ensure your electrician places a neutral wire in every single switch box to provide that continuous power. Technology advances quickly, and we cannot predict exactly what cables will be required 10 years from now. To prepare, you can have your builder run a completely empty plastic pipe from your central media panel straight up into the attic space. If a completely new type of antenna is invented, you already have a clear, hollow pathway to pull the new wire through. Centralizing your equipment and leaving empty pathways means the house can adapt for decades without anyone ever tearing open your finished drywall. This floor plan organizes your system before construction. Create a data map for your builder. Mark specific nodes. 2 connections behind every television, 2 at your office desk, 1 on exterior corners for cameras, and 1 in the garage for future electric vehicle chargers. When you hardwire all of these heavy, data-hungry devices, you physically remove them from your shared wireless network. This frees up the airwaves, drastically speeding up the wireless signal for devices that actually need to move, like your phones and tablets. You have the power to guide your contractors. Instead of accepting standard wireless compromises, specify shielded data cables and direct home runs right in your initial building plans. By building out this hidden physical infrastructure, you lock in reliable internet speeds and climate-proof security. You build a resilient home ready to handle the heavy technological demands of the next decade. If you found these building strategies helpful, please subscribe and like the video to learn more ways to design and build smarter homes.